Hello guys, this is teacher Victor. As I promised, I said I will be taking you through mathematics, physics, then I have extended that to give you additional benefit of studying business and geography along this channel. I am a graduate from ZTech University and I've decided to start this channel especially to help those people with difficulties in solving mathematical problem and physical problem through this channel. So the first law, what you're going to start with is the indices. Indices, before you tackle any question of indices, you must know the laws of indices, and I am going to explain every law. Then I'm going to give you an elaboration. This is going to act as my board, and this is going to act as my note, where I'm going to explain to you everything. So the first law of indices: if you are multiplying with the same base, we simply add the powers. What do I mean? If you are multiplying with the same base, you simply add the powers. So for instance, if you have x raised to power a, you have x raised to power a, then you have x raised to power b. This is, we are going to add the powers a plus b, so that we get that. So for instance, if you have 2 raised to power 2 times 2 raised to power 3, 2 raised to power 3. So if you have that 2 raised to power 3, so we are simply going to add 2. So you have the same base, so the base is 2 in this particular example. So the base is 2, then the powers is 2 and 3. So we are going to add 2 plus 3. So this is going to give us 2 raised to power 5. 2 raised to power 5. 2 raised to power 5. So if you have the same base, and you are multiplying, we are supposed to add the power. So that is law 1. Law 2, if you are now dividing, with the same base, we simply subtract the powers. For example, if you have let's say 4 raised to power y, then you are dividing with 4 raised to power, let's say x. So we simply subtract the power. So we're going to have 4 raised to power y minus x. So if you are dividing with the same base, we simply subtract the power. So that's why we have subtracted y minus x. So if you are dividing with the same base, we simply subtract the powers. So that is what we have said as law 2. So law 3, if you have law 3 is this. So law 3, so you have x raised to power a, then all of that is raised to power b. Then we are going to simply multiply the power. So what do I mean with that? So you have a raised to power m, then all of this one here is raised to power n. Then what we simply do, we are going to have a raised to m n. So we simply multiply the powers. So you are going to get a raised to m n. So that is law 3. So the next one here, the next law is this: xy raised to power a. Xy raised to power a is the same as everything in that particular is going to be raised to power a. So what do I mean? So if you have x, then you have y here, then all of this is raised to a particular power of a here. So this means that x was raised to power a, then y was also raised to power a. So this is what this particular law means. So it means that x was raised to power a, then y was raised to power a, but now this one here is not the same as, so if you have x raised to power a, then you have y raised to power b, so this is not the same. So we have different powers, we can't group them. So this is different from this. So you must know. So if it is xy raised to power a, this is the same as x raised to power a, then y raised to power a. So this is that particular law. So we move to the next one, the reciprocal. So any number raised to negative, any number raised to negative, if you want to remove that negative, you simply get the reciprocal of that. So what do I mean with that? So in this particular case, you have x raised to negative a. So this is the same as 1 over x raised to a. So you simply remove this negative by getting the reciprocal of this, then you get this. So remember that, very important. So any number raised to a negative, for us to remove that negative, we simply get the reciprocal of that particular number, then you get that. So this, let me elaborate further. Maybe you have not understood what I'm talking about. So if you have x raised to negative 1, so this is the same as 1 over x. Now if you have, now for instance, in that particular case, you have x raised to negative a, so this is the same as x raised to negative 1, then all of this is raised to a. So this one here simply means, so the reciprocal of this, you're going to have 1 over x, then this one is raised to a. But remember, 1 raised to any number positive, any positive whole number, 1 raised to any positive whole number is the same as 1. So you're going to have 1 over x raised to a. That's why we are saying that 1 x raised to negative a is the same as this one here. I have explained that, now it is clear. Let's move to the next one here. Any number raised to power 0 is equals to 1. Any number raised to power 0 is equals to 1. Any number raised to power 0 is equals to 1. So any number raised to power 0 is equals to 1. Any number raised to power 0 is equals to 1. Prove. How can you prove this, Mr. Victor? Is it possible? Are you saying the true thing? So this is very true. So for instance, you have 5 raised to power 3, then you are going to divide this by 5 again raised to power 3. From the second law, we said if you are dividing with the same base, we simply subtract the power. So you're going to have 5. So you're going to have 3 minus 3. So you're going to have 5 raised to, so you're going to have 5 raised to power 0. But you have said any number raised to power 0 is equals to 1. So is 5 raised to power 0 equals to 1? Yes, it is equals to 1. Why? So let's do like this. So you have 5 times 5 times 5 all over, we are going to divide by 5 times 5 times 5. So we are proving that. So this goes here once, this also goes here once, this goes here 1. So here we are going to have 1 times 1 times 1. You are going to get what? 1. So that's why you are saying any number raised to power 0 is equals to 1. I have explained that. Let's move to the next law. So you have a raised to power x over y is equals to y root of a raised to power x. Mr. Victor, kindly explain that. I'm going to explain that to you. So this is what we mean. This is what I mean. So you have a raised to x. So you have a raised to x over y. You have said this is the same as the y root of a raised to x. Mr. Victor, explain to me this so that I understand what is happening. So the first thing we are going to talk about is this. We said very categorically that this one here can also be written as a raised to x, 1 over y, then all of this is raised to power x. Then remember, 1 over the number is the same as 1. Any number raised to 1 over any number is the same as the root, the nth root of that particular number. So what do I mean with this? So let's first deal with this one here. Or this one can also be written as, somebody can also say, so you have a raised to x, then the whole of this is raised to 1 over y. Yes, that is right. So now this, you are going to have the y root of what? A raised to power x, and that is how that particular law is coming about. So that is what you're supposed to know. So that is okay. So we are going to the minor things which are always there in exams. So if you have this, if you have a raised to power y is equals to a raised to power x, what do we normally say? We normally say that y is equals to x. This is a very common question in KCSE. So you will be given 72. So let's say we have 72 raised to power x is equals to let's say something like 32 raised to power y. So if you're given something like this, kindly note this. So the first thing you're supposed to know, 72 is the same as 9 times. So 72 is the same as 9 times 8. 72 is the same as 9 times 8, but all of this is raised to power x. 32 is the same as 8 times 4. 8 times 4. 8 times 4. 8 times 4. So all of this is raised to power y. So if you are given a question like this, then you know that. So here we are going to have 9 raised to power x times 8 raised to power x is equals to 8 raised to power y times 4 raised to power y. So because you have the same base here, so it means the power to which 8 is raised to is the same as the power to which 8 is raised to on the other side. So that now we are going to say y is going to equals to x of this side. Then here, because now here you have base 4, here you have base 9, so it is not going to be possible to compare base 9 with base 4. So, but we are going to compare base 8 and base 8, where x is equals going to be what? Y. So that is right. I have explained that. So let's move to this question, example 1. You have simplify 32 raised to negative 0.4. So how are we going to solve that question? So you have 32 raised to 0.4. Kindly, I have the calculation is already done, but I need you to understand what is happening here. So now this one here is very simple. Why are you saying it is simple, Mr. Victor? The first thing you're going to say, we said for us to remove this negative, we simply get the reciprocal of that particular number. So you're going to have 1 over 32. It is now raised to 0.4. But remember, 32 is the same as 2 raised to power 5. So 32 is the same as 2 raised to power 5. So what are we going to do? We are going to say this is the same as 1 over 32, which is 2 raised to power 5. So you are going to have 2 raised to power 5 here. 2 raised to power 5. Then remember, the all of this is raised to 0.4. From the law we said we multiply the powers. So we are going to have this is going to be 1 over 2. Then we have 5 times 0.4. We are going to have 5 times 0.4. We are going to have 2. So you are going to have 2 raised to power 2. So this is going to give us 1. 2 squared is the same as 4. So you are going to have our answer as 1 over 4. I have explained that. How it is coming about. So the first thing you're supposed to do, we are supposed to do away with this negative. How are we going to deal away with this negative? We are going to get the reciprocal of that. We are going to have 1 over 32 raised to 0.4. The next thing, 32 is the same as 2 raised to power 5. Then we are going to multiply the powers. So 5 times 0.4, we are going to have 2. So you are going to have 1 over 2 raised to power 2. We are going to get 1 over 4, because 2 raised to power 2 is 4. That is the answer of that. Example 2. Simplify the following expression. So you're supposed to be very careful while dealing with this. A very simple question. Remember, for us to deal away with this negative, what we are going to do, we can simply multiply this negative with the powers inside the bracket. So you have negative 1 times a half, you are going to get negative a half. Then negative 1 times negative 1 is positive, which you are going to have b raised to power 1, which is just the same as b. Then we are going to the denominator here. Again. So here you are going to have 3 raised to negative 1. So negative 1 times negative 1 is going to be 3. Then we have b raised to negative 2. So 2 times negative 1, you're going to get negative 2. That is what is happening here. Divide by. So again, the same laws applies here. So you're going to have 3 squared times. So negative 3 over 2 times 2, you are going to get 6 over negative 2, then b squared, so you have 2 times 2 is 4, then you are going to have this here. So once this is simplified the way it is, what we are going to do here is again a very simple mathematics, Remember, if you are dividing by a fraction, you simply multiply by the reciprocal of that. So that is what is happening here. So the reciprocal of this is going to be this one here. The reciprocal of this is going to be this one here. So now we are going to have this simple mathematics. Remember, we have here a raised to negative 2 raised to negative a half times a raised to 6b. So what are we going to do here? We are going to add negative a half plus 6 over 4 plus 6 over 4. Maybe you are not understanding what I'm saying. But I'm saying like this. You can see we have a here raised to negative a half, then you have b raised to power 1, then we are multiplying by this one here, then we are going to divide by this. So what is happening here is this one. You have base a, then you also have base a we are dividing with here in the denominator. So you are going to have a raised to negative a half times a raised to 6 over 4 divided by a raised to negative 6 over 2. Remember, from law 1, if you are multiplying, we add. So you are going to have a negative a half plus 6 over 4 minus 6 over 2, because this is a. That is right. I think now you get what I'm saying. Then you have b raised to power 1 times b raised to power 1 minus b raised to power 4. So we are going to subtract the powers. We are going to subtract the powers here. We are going to subtract the powers. So that's now what is happening here. From a very simple, let's move to step this. A very simple that explanation. Then once you do that, so you have this raised to negative a half, this one here, this. So we are going to so you have negative a half plus 6 over 4 minus 6 over 2. This, you are going to get a. That. So if you follow what I'm saying correctly, you are going to end up with this, then you end up this. So that is what you're supposed to do. Let's move to the third example. So you have this. So you're told to simplify the expression. So you have 3 raised to power n times 6 raised to n plus 1 times 12 raised to n minus 1 all over 3 raised to 2n times 8 raised to power n. Very simple. The first thing you're supposed to know is that 6 is the same as 3 times 2. That's what you are seeing here. Then all of that, remember, it was raised to n plus 1. So it means each of these is going to be raised with this. Do you remember that law I said? Yes, I think you remember. Then 12 is the same as 2 times 3 times 2 raised to that. So what is going to happen? The denominator, we have this. So 8 is the same as 2 cubed. So 2 times 2 times 2 times that, 8 cubed. So that. So once you have the whole of this, so you have 3 raised to power n, then you have this 3 raised to n plus 1, then you have 2 raised to n plus 1 times 2 squared. So 2 times 2 is 2 squared. This, all of this is raised to n minus that times 3 raised to power n minus 1. That is it. Then from that, you are going to have a very simple summary of that. So you're going to have 3 raised to n plus 1 plus n minus 1. Again, on this side, you're going to have 2 raised to n plus that plus that plus that. So once you do this, you're going to get this one here. Then remember the law. Remember the law. If you are dividing the same base, we simply subtract the powers. So 3n minus 2n, you're going to get n. Then 3n minus 1 minus 3n, you are going to get minus 1. So here you're going to have 3 raised to power n times 2 raised to negative 1. But remember, for us to move the negative, we simply get the reciprocal of that particular number. You're going to have a half. Then you're going to have 3 raised to n all over 2 as your final answer. As I said, I am planning, and if you are really willing to support me, get a camera and a board where I will be doing these calculations as I explain. Then it will be better for us. I think you have understood how to do this example 3. Example 4. Example 4. You are told to simplify the expression. You are told to simplify the expression. You are given 3 over x raised to negative 1 plus 2 plus 1 over x raised to negative 1 minus 2. You are told to simplify that expression. The first thing you're supposed to know, we said any number raised to negative. Any number raised to negative is the same as getting the reciprocal of that particular number. So that is the very first thing you're supposed to do here. So that 3 over 1 over x plus 2 plus 1 over x minus 2. So if you do this from your algebra, you must get the LCM. The LCM of 1 over x plus 2, then LCM of 1 over x plus 2 and 1 over x minus 2. A very simple calculation that I will be dealing with. A very simple calculations. Then step 2 now, once you have that, you can see the LCM of that is 2 over x plus 1 over x bracket 1 minus 2x over x, that is the LCM. Then now we must remove the denominator by multiplying it with each of the numerator to give us this step. Now kindly focus. If you have any question, you can ask. I will be explaining it to the maximum. I am willing to explain this thing even 10 times so that we understand. If you have any question, please put it on the comment. I will be explaining it to you. As I said, you can also have me as your online tutor, where I will be teaching you directly in a class, online class, obviously at a small fee. Don't fear to contact me. Let's proceed. So the next step, the LCM is already gotten, so we are going to multiply everything with that particular LCM. So you must check how many times does 1 plus 2x bracket 1 minus 2x goes into that particular LCM. You are going to have it goes there 1 minus 2x times. So you multiply 3x times that. So if you expand this particular LCM, you are going to have 1 minus 4x squared, 1 minus 4x squared. So that then if you simplify that, you are going to have 4x into 1 minus 4x all over 1 minus 4x squared. That is that. Very simple question and direct. Example 5 is a very simple question you have talked about. So you are given 2 raised to x minus 1 is equals to 16. Then you are told to solve for x. You are told to solve for x. So you are given 2 raised to x minus 1. So you have 2 raised to x minus 1 is equals to 16. You are told to solve for x. So this is very simple. So you have 16 is the same as 2 raised to power 4. 16 is the same as 2 raised to power 4. So you're going to have 2 raised to x. You're going to have 2 raised to x minus 1 is equals to 2 raised to power 4, which is the same as 16. So we simply compare the powers if the bases are the same. So you're going to have x minus 1 is equals to 4. So here I'm going to collect like terms. So x negative 1 is going to cross equal sign. It is going to be addition. So you're going to have 4 plus 1. So this is going to give you x is equals to 5. X is equals to 5. So that is it. So you can see directly from what is happening. I have explained that. So the next one you are told to solve for x. You are told to solve for x. You are given, let's see what you are given. So you are given 4 raised to x. 4 raised to x. You are given 4 raised to power x. 4 raised to power x minus 2 raised to x plus 3, x plus 3 plus 16 is equals to 0. So you are told to solve for x. You are told to solve for x. I'm going to explain what you are supposed to do as a student. So 4 raised to power x. So 4 is the same as 2 raised to power 2. So you are going to have, that is going to be 2 raised to 2x minus 2 raised to x times 2 raised to power 3 plus 2 raised to power 4 is equals to 0. Remember this. So Mr. Victor, why are you doing this? Why have you decided to split this? From the first law you said if you are adding, you simply multiply. That's what I have done here. So the next thing we said any number raised to power 0 is 1. Any number raised to power 0 is 1. So the next thing we are going to do, we are going to split this or group there. So here we are going to have 2 raised to power x into 2 raised to power 2. So here we're going to have 2 raised to, so here 2 is common, so here we're going to have 1 squared, which is the same as 1, minus 1 raised to power x. So here you have 2 raised to power x, so 2 raised to power x, so here we're going to have 1 square that times 2. So here you're going to have 1 cubed plus 1 raised to power 4. So that is going to be 0. Kindly, writing on that is becoming difficult a little bit, but I think with time, once I get aboard, I will be explaining to you what it takes. It might be boring to write like a baby on the board. As you can see, I'm trying to write, but it's not coming clearly. So you see now this, it is not coming clearly, and it might not be clear for you. So kindly adhere with me as I explain to you what is happening in step 1. That is the question. So remember, 4 is the same as 2 squared, then all of that is raised to power x minus 2. Then remember, we said if you are multiplying with the same base, we simply add. Now if you go to the reverse of that, you are going to have 2 raised to power x times 2 raised to power 3 plus 16. That, then remember this. So here you are going to have 2 raised to power x. Here you have 2 raised to power x. Then here you have 8 plus 16. So 8 is coming from here. We have 2 raised to power 3, which is 8. So the next thing you're going to do here, so if you multiply this and this, so you're going to have 2 raised to power x squared minus 8 raised to 2x plus 16. So the first thing you're going to do, you're going to say let 2 raised to power x to be any number. 2 raised to power x to be any number. So in any place you have 2 raised to power x, you are going to replace with a. You are going to replace with a. So what do I mean with this? So here we have 2 raised to power x. We are going to replace it with a. We are going to have a squared minus 8a plus 16 is equals to 0. Then from here we are going to have quadratic equation. We are going to have a quadratic equation. The first identity of quadratic equation, we have a minus b, a minus a squared minus b squared is equals to a plus b bracket a minus b bracket. So this is a perfect square. So you are going to have a minus 4, all of this is squared, is equals to 0. That, so here you are going to a minus 4 is equals to 0, or a plus 4 is equals to 0. So you are going to have a is equals to 4. A is equals to 4. But remember, we said a is equals to 2 raised to power x. So therefore, if a is equals to 4, then we are going to simply substitute here. So we are going to have 2 raised to power x is equals to 4, which we said that. Remember, we said let 2 raised to power x be a, and a we have gotten to be 4. So it means 2 raised to power x is going to be 2 squared, where x is going to be 2. That. If you have any question, kindly consult me. I will help you solve it out. So that is all for indices. That is an example of indices where we are going to that. But there is something I'm forgetting here. Before I forget, if you are not given the same base, what are you supposed to do? If you are not given the same base, what are you supposed to do? We are going to introduce logarithms. If you are not given the same base, we introduce logarithms. So like this. So you have 2 raised to x plus 1 is equals to 12. Remember, you cannot express 12 in the base of 2. So what are you going to do? You are going to introduce logarithms. So the next topic we are supposed to talk about is logarithms. So I am going to stop there for now. That is all about indices. If you have any question, kindly put it on the comment. If you have a question which needs to be solved or is giving you a problem, I can help you solve it out. Kindly put it on the comment section. Thank you. This is Teacher Victor. This is mathematics first class. I've done for now.